Hi students, welcome to your Spiral 3 review. Mr. Butterworth, does that mean Spiral 3 is coming up?
It does, Mr. Carlson.
That's so exciting.
I am so excited, I just can't hide it.
Are you about to lose control and you think you like it? You like it?
Yes.
That's a song. So if you don't remember when that song came out, to be fair, I think that may have been before either of us were alive as well. I was about to make fun of how young you were, but that's fine. Okay, so we're trying to do some graph analysis with quadratics. And the first thing is to put this function in Desmos and to paste the image below. This is an important piece of this because we need to be able to see where you're getting your information from. And it's good practice for pasting things.
And
Mr.
I'm slow
Butterworth.
playing this because I wanted to talk about it for a moment first.
Oh,
So
excellent.
simply looking at the equation, that's a +3 in front. So because that's a +3, I should know something about the shape of the curve. I'm not going to tell you it because I'm going to paste it in a moment, but I should know something about the shape of the curve. The second piece is this equation is in vertex form. That might suggest that I should be able to identify the vertex. So without even looking at the graph, I should be able to find some of these things. If you can't right now, that's okay. But that might be something that's worth thinking about and looking into, and maybe talking to one of us about and figuring out how to find those pieces I just talked about and what that 3 tells us. So here's the graph with
Ooh,
all its important pieces.
that is a lovely, lovely graph.
I picked purple.
I like it. Okay, so the first thing that I notice is that we're being asked if this graph is concave up or concave down. We've also described these as like parabolas that open up or open down, or smile parabolas and frown parabolas, and any number of different ways to talk about this. This looks like a parabola that is opening up to me, and that means that we are concave up for this parabola.
I agree.
Hey, does that connect to something that you were just talking about in that equation, Mr. Butterworth?
It does. The number 3, that's what tells you that that function is going to be concave up.
Why is that?
Because the 3 is positive, that makes the curve go up. If the 3 were negative, then the curve would go down.
Excellent. You did. All right. How about some X-intercepts here?
So the X-intercepts just show up right on the graph there because I clicked on them.
Oh,
So
that
the
seems like something that
X-intercepts
would be really useful to do.
it would be. And the X-intercepts are points. Now these are approximations, but negative 3.816 comma 0 and negative 2.184 comma 0 are going to be your X-intercepts where we cross the X-axis.
I feel like we did them a very nice favor by creating this problem to be used in Desmos instead of solving that algebraically. Those seem like gross numbers.
They are.
All right. Then we've got an axis of symmetry. And I know that being symmetric means that it can like fold over on itself. So that sounds
true.
like we're looking for a line that goes through the center of this parabola.
It is. And so we have to
like
write
that,
the
right?
equation of the line.
It's like this line, right?
Mr. Carlson, that is not through the middle of the parabola. You have to think about symmetry, my friend. Yeah, buddy, that's the one.
There we go. Hey, and notice that goes through this bottom point. Does that have a name?
It certainly does. It's very important.
It's kind of vexing to think about that.
Oh, I see what you did there. I heard it was called the vertex.
Okay, and here we've got the point -3 comma -2. And I know that vertical lines have the same x value going up and down the whole thing. So that's really about the x value here. X equals -3. Sounds good to me.
That sounds great.
How on earth can we find the y-intercept?
Well, so the y-intercept is where we cross the y-axis. So that would be when x is 0. And we can tell that because, again, I clicked on it. It doesn't automatically show up. But because I clicked on it, it's right up there, as Mr. Carlson just circled. And so that is your y-intercept. Write it as a point, though. Don't just tell us 25. Write it as a point.
So you're telling us that if you click on the gray dots that appear on your graph, the points that Desmos thinks are important, it will show up with numbers there?
Yes,
That's
indeedly doodly.
That seems mightily convenient, sir.
It is.
All right. So,
this is a different form.
ooh,
Before we talked about vertex form. These are in factored form. So what we would love to see on your quiz is for you to identify the form. That would be great. But then the important features. So like we talked about on the previous page, that -3 is going to tell us concave down. I forgot how to spell there for a minute. I'm sorry. And then my zeros are going to be -5, 0 and -2, 0. And if you can write that down for us, that's giving us some information. Oh, I just did not spell concave correctly. I'm going to try that again.
no, you're good.
And if we look at the graph on the right, goodness, I can't write concave down.
That looks
We
worse
could
than it did
pretend
before.
it does. I'm just going to erase it and it will magically appear later. That could be -5, 0, and then that could be -2, 0. And that curve is concave down. So sure, that works. So you should say, yes, this one could work. And then you should do the same idea for B. For B, you should say, okay, that's got to be down again. -2. I'm going to try again. Concave down. And then I can't write concave. And then the zeros are -2, 0 and 3, 0.
Mm. So, like, either of these could believably be -2, 0, depending on the scale. But 3, 0 would have to be somewhere on the positive side of the x-axis. So I feel like this one doesn't work because of that.
I agree. Look, it says concave down now.
I like it.
Alrighty, so this next one, this is in standard form. So the first one of the things it says over there on the right is to insert your graph. So I put the graph into Desmos. I clicked on some important dots.
Mr. Butterworth, do you think this is a good first step?
The graph?
Yeah.
Yes.
Okay.
I think I would do that first. I think that would be my first go, would be put the graph down. And then as Mr. Carlson said, we have those gray dots. We can click on those, and those are important. So from those gray dots, we should be able to identify some things.
I noticed that.
And by some things, I mean
some of the things that we're being asked about.
Yeah. Like
Wow.
the vertex.
Oh, and that's the bottom point of this graph, or if it was an upside down one, would be the top point. So that would be at -5, 15. And then we also said that has something to do with another one of these things we're being asked to identify. I like that there's some lag in my video now again. That's always fun.
That's fine. I knew you wrote it down because you said it.
And that thing that this goes with is that axis of axis of symmetry, which goes right through that vertex. And we know that vertical lines have the same x value all the way up and down. So it's going to be an x equals equation. The x point here is -5.
And if you're not sure that you got that right, you can put it in Desmos and see if it matches.
You mean you could try things and it might work?
Yeah. So the blue
awesome.
line going straight up and down there is the x equals -5 Mr. Carlson just talked about. So you can use Desmos as a tool to help you.
All right. The next thing I see is a Y-intercept. And by golly, I think that's on this graph also.
I agree.
Because I see a point on the y-axis that's been marked, and that's at 0.40. All right, and the next question looks a little bit spicy.
But I like things that are spicy.
I do too. Spicy foods, they're the best. Spicy math problems, even tastier. So we're asked for X-intercepts, but my x-axis is down here, and I don't see any. Why?
Well, when I was talking to one of my classes, what we talked about is that's because the curve is just too high, so they have to be imaginary zeros. So if the curve does not touch or hit the x-axis, then we're going to have imaginary zeros. So we don't have any x-intercepts.
So we have imaginary zeros instead of x-intercepts.
Yeah. Well, that was fun.
Yeah, I must have touched the screen to have it zoom or something.
Now, in order to find those imaginary zeros, we gave you a website that I have put on my website. It's going to be on the next page for this, but you can use a website to help you figure things out. So when Mr. Carlson clicks to the next page, what I did is I showed you everything I put in. So all I put in was what's up in the search box there, solved by completing the square, x squared plus 10x plus 40, and it did all the work for me.
And am I correct in saying that if you click the link, it gives you this, so you really only have to type in the equation?
Yes. Unless you don't want to solve by completing the square, and then you have to do something a little different.
Cool. And I notice that we have a line here that says the solutions are, and gives us some solutions.
Yeah, it gives you up here. I wanted to screenshot the whole thing. You didn't need the whole thing. It tells you the answers right there. I would prefer these written as -5 plus or minus I square roots of 15. That makes me more comfortable in terms of how that is written, and it won't look like the I is sliding underneath the square root. So feel free to write it that way. But those would be the zeros that we're looking for from the previous page.
Yeah, we were talking about that today in my class too, that it's okay to write things as like squared 15 times I, but you got to be real careful that the I doesn't slide underneath the square root. And sometimes it's not all of us have amazing handwriting like me. So, if you have messy handwriting, that may be an issue. All right.
I definitely do. So that's why I do it, because otherwise it'll look like you have the square root of 15 I, and I don't know if the I is supposed to be under the square root or not, and that's a sad face. So don't do that.
Oh, there's the other I. Okay.
It erases when I first do a little circle.
Yeah. Part of it depends on what implement that you're using. But anyway,
we did it for
that's it.